Okay, we continue with an API. We just summarize, discuss, if I can say, the three data formats that we have: JSON, XML, and YAML, right? Which are used basically in network automation, as we will see. I think that is the foundation of all the tools that we are going to be using. If you want to automate a network, the data format, the language, the representation of text is in those three formats, and it is very uh, well understood by the devices that we use. Right. Now, going to the API concept. By definition, an API is a software that allows other applications to access its data or services. A set of rules describing how one application can interact with another and the instructions to allow the interaction to occur. The user sends an API request to a server asking for specific information and receives an API response in return from the server along with the requested information. Right? To simplify things, an API is an interface that allows softwares to communicate, different softwares, different applications. Right. So there is then essentially not only for network automation, as we will see, but almost a number of applications are now using APIs. And this is how it works basically. It works the same way as if you want to access something per browser, you have an HTTP request, a request you enter, then the response, you get the web page via probably HTML, then you view something on your web page. API works in almost the same way. So a client sends a request to the API, which is the interface. The API receives that request, processes it, and sends back a response to the client. So the response in this case will be in the data format, those three data formats. It will either be in JSON, XML, or YAML. Now, an API is similar to a waiter in a restaurant, as shown in the following figure. All right, similarity, if you're a client, you want food, you call the waiter, which is your API. You tell the waiter which type of food you want. The waiter goes probably to the kitchen, gets the food you order, or Zokanai. So an API works in the same way. A perfect example here, function API. If you are using probably a weather app, you request to weather muharare avondeo yakamira sei. An API goes to that specific location, or my applications, I need that information. An API, the interface, goes to that application and gets information everywhere that avondeo yakaita sei. Then it retains that information via request. So an API works sort of as a messenger between my applications. So if an application wants some information from another application, it communicates with the API. An API, you need a runner to go and get information from different applications. Like, why it's important understanding my API is because when we talk of network automation, API rinenge runner to get and collect information from multiple devices, also push configurations to multiple devices. So it's very important understanding the concepts of an API because I think all of network automation iri panarana here. Ndianenge achiisa information kuma devices also collecting information from those devices. Right, API. An API example. To really understand how APIs can be used to provide data and services, we'll look at two options of booking an airline reservations. The first option uses a website of a specific airline. Using the airline's website, the user enters the information to make a reservation. The website interacts directly with its database and provides the user with information matching user requests. I think here is just a demonstration of making a reservation using an API or without using an API. Let me see. So here we don't have an API, and here this is an example with an API. And the difference is if I'm accessing my information directly from the website database, information I don't wanna, in this example, I'm making a reservation. Information I don't wanna is for that specific airline because I'm interacting with only its database, one specific airline. But if you have an API rinokwanisa kuita run for airline A, airline B, airline C, D, E, F, G. It goes and gets information from all those websites, all those databases, if I can say, all those databases, different databases. Then it retains that information. So some of my applications, I cannot tell by name, but some of my applications, for example, if you want to book a hotel, unoenda pa-application unotaura kuti ndoda kugara kuVic Falls for this many days. Woisa request yako, then that application uses an API kuenda kuma-hotels ese ari muVictoria Falls, otora information yese nema-prices, iwo ngolistira kunzi hotel iyi for a night imari iri papi, iyi for a night imari iri papi. Then you have to choose. So an API is very integral in some of those applications. Instead of going only per one hotel, one information in one hotel, you want to have an option. You have to choose which one can I choose depending on my parameters on Ngwapiu. So an API is very important, not only in network automation, but in quite a number of applications. Another one, Google Maps, also uses API, by the way. Quite a number of applications uses API. Right, open internal partner APIs. Some of these things, I think this network automation course is about understanding just my definitions. There is not much of programming here. It's just definitions, understanding my definitions, comparing my data formats, for example. Not much programming knowledge required. Right, open internal partner APIs. An open API is a publicly available API. POVO, right? That is for everyone. Example, Google Maps is for POVO. And I think the reason why some of my APIs are public, most of them, is so that you can promote innovation at variable bands, so that you can promote innovation and stuff like that. Then we have internal APIs. Those are within organizations. An example, being an API allowing authorized salespeople access to internal sales data on their mobile devices. In simple terms, a private API is for the organization. No one else has access if not from within the organization. Then a partner API, this one is shared by partners or a select of, this one is shared by partners, or sometimes you can give access to developers to your API. An example, a travel service using an airline's API is an example of a partner API. So I think a partner API, you allow access to some partners, right? You have an internal, you have your private API first. Then you allow some partners to have access, and that defines a partner API. This one sounds a lot like definition here, internet, intranet, and extranet, almost the same thing. Let's go. Types of web service APIs. The web service, a web service is a service that is available over the internet. And we have 4 types of web service APIs. Simple Object Access Protocol, representational state transfer, which is the most popular and the one we will learn in this course, that is REST. Then we have XML RPC, then we have JSON RPC. In their characteristics, you can see from the data formats, this one, it has all the data formats. I think probably that is why it is most widely used. Right, REST. Right, let's go through REST. What is REST? Let me see, REST. Representational state transfer. Representational state transfer, okay, REST. Web browsers use HTTP to get requests. If successfully requested, we get a response. Web servers respond to get requests with an HTML coded web page. Language here is not very complicated, but you're doing this almost every day. Or Google or anything. If you type in your website, that is the request that you are sending. And what you get back on the page, that is the response coded in HTML, probably. That is the response that you're getting. That is HTTP for you. Now, an API, which is built on an HTTP protocol, is what we call a RESTful API. Very simple. HTTP protocol API interface. If an API is built upon the HTTP protocol, it's called a RESTful API. So simply stated, a REST API is an API that works on top of the HTTP protocol, and it defines a set of functions developers can use to perform requests and receive responses via HTTP protocol, such as GET and POST. They're a bit different, but I think the concept is still the same. Conforming to the constraints of the REST architecture is generally referred to being RESTful, okay? An API can be considered RESTful if it has the following features: client, server, stateless, cacheable. The client handles the front end, the server handles the back end. Either can be replaced independently of each other. No client data is stored on the server between requests. Right, so I think in summary, what we need to get here, in a typical exam question, definition REST is an API, a RESTful API. API built on top of the HTTP protocol. If it's built on top of HTTP and it uses almost the same concept and the methods that HTTP uses, for example, GET, then it's called a RESTful API. Let's look at some of the methods. Voila, here they. A RESTful web service is implemented using HTTP, a collection of resources with 4 defined aspects. Right, a RESTful API, it has these following. We have what we call a resource identifier, a URI. We'll define it later. The data format supported by the web service, which is often JSON, XML, YAML. So it has the URI, an API. It is defined by a collection of resources. Number 1, the URI. Number 2, the data format. Number three, the methods which are being used, and these are the methods right here. We'll get through them. Then lastly, the API must be hypertext driven. RESTful APIs use common HTTP methods, including post, get, patch, and delete. As shown in the following table, these correspond to RESTful operations: create, read, update, and delete. If you want to create, if you want to read information, if you want to update, and if you want to delete. This will be very important for my exams as well. CRUD. Right. So in HTTP, my methods in HTTP, we have post, but in API, RESTful APIs, to be more specific, we have create, get, read, put, update, delete, delete. I think typical question, you are going to get matchmaking for my questions are HTTP on one end, RESTful operation on one end. On the matchmake, which one is post, which one is get, which one is put, and which one is delete. These are the methods that are used in RESTful APIs. Almost the same. Why? Because a RESTful API is built on top of the HTTP protocol. So the way they function is almost the same way the HTTP protocol functions. Right, URI, URN, and URL. By definition, a URI, let me see, Uniform Resource Identifier, URI, Uniform Resource Identifier. All right. By definition, a URI identifies a network resource. Where do you want to get your information? It identifies that resource. And it is defined by those two, the URN and the URL. One identifies the specific location of the resource, usually identified by the protocols, that is the URL. Right there. That is the start of the URL, defined by the HTTPS protocol in this example. It can be either of these, right? Then the name, which identifies the name of the resource. So as you can see, Panap, this is the URN. This is the URN right here, right? Then you can evidently tell could the URN plus the protocol defines the URL. So the URI, this is the URI. Everything there. The URI, it identifies a network resource. So kana uri kuda kutsvaga a specific location by Google Map, you use an URI kutsvaga that specific location. Within that URI, meaning URL and URN, the name and the locator, the location. All right? The location is usually identified by the protocol which is being used. Then the name, it just identifies the name of the resource. Very easy. Typical example questions, typical questions in an exam to apply this knowledge. Excuse me. We're not going to go pure something like this. Of ones identify with the URL in the heap and URL in the heap. It is very easy. If you know URL, we use the protocol, Lopanepane protocol. URL is just the name. Right. Then we also have, let me see. That's it. Yeah. Anatomy of a RESTful request. In a RESTful web service, a request made to a resource URI will elicit a response. The response will be a payload typically formatted in JSON, but could be HTML, XML, or some other format. Making this simple, tikadzoka ku HTTP, very, very easy kunzwisisa. Ku HTTP request ndinoisa website rangu URL. Ku HTTP request my URL only. Yes, a URL yangu. Then I get back information in the form of website. You know, display something, right? That is the payload irudzoswa. Kuma APIs, more so my RESTful APIs. Chinodzoka is data which is formatted in JSON. So the data that radzidza kumashure, the format, that's the response that you get back. Then if you want, that data can then be converted, probably Tambotarout is more related to JavaScript, back to JavaScript, then you can see it as a website. But in this case, information is being the payload. It is being responded in the format here, the JSON. There are different parts of an API request. API request in the API server, which is the URL of the server that handles the incoming API. So in this case, we have the MapQuest API, and the URL of that server is this one. So request your API. Some of the components that is yes, it has that the API server. Number two, it has the resource. And the resource represents the data that the API interacts with. Right? It specifies the API that is being requested. And in this example, we are requesting my directions. All right, at MapQuest, we are requesting my directions. So this is the resources, right? Then we have the format, which is a combination. Let me see, not the format. Right, we have the format, which in this case is JSON. It can be XML, it can be YAML as well. So this is the format of the request. JSON. Here in this case is JSON. After that, we have the key, which represents the key pair values, usually used for authentication purposes. So if an API request is made, the response can also key. It means you cannot be authenticated, you cannot view that information. So my APIs that root are private. It's probably because of this key right here. Can also key you won't be able to use that API. Right? So a combination of this, the format, the key, and the parameters forms what we call the query. My parameters, they are used to send information pertaining to the request. And in this case, the information here includes information about the direction that the API needs, so it knows what directions to return. So I think API ndo ine results ataona kwekutanga. I think it's requesting the location of San Jose, right? The API request, it will request what is the latitude, what is the longitude of San Jose in Monterey, California. Then the information that comes back after that request, then I get something like this. I think it's now making sense. Where is it? This one right here. This is the response. So if it is in JSON format, after that API request, what you get back is this. Okay, right. And Panapa as well. Typical exam questions. unongopiwa this API request, right? Of one's mesh make. What is the format? What is the key? Key up or something else. You see the key like this. Some characters. What is the key? What is the key? What are the parameters? What are the resources? And what is the API safe? That is a typical exam question. So you need to know the format, yeah, an API RESTful request. Right. Then here are some reasons why an API provider may require a key. The reason why there is a key, number one, authentication, like I said. If you want to have a private API, then you need a private key. To limit the number of people using the API, to limit the number of requests per user, to better capture and track data being requested by users, and lastly, to gather information on the people using the API. I think in general, it's so that not everyone gets access to the information via your API, not get access to information in rule request or being responded by the API. The MapQuest API does require a key. Search the internet for the URL to obtain a MapQuest key. Use the search parameters developer MapQuest. You can also search the internet for the current URL that outlines the MapQuest privacy policy. So this one I think is partially public, this one, because it's available over the internet. Right, applications. RESTful API applications. Many websites and applications use APIs to access information and provide service for their customers. Some RESTful APIs requests can be made by typing in the URI from within a web browser. The MapQuest Directions API is an example of this. So there are several ways that we can make an RESTful API request. Right, one, develop a website. So directly on the website, developers often maintain websites that include information about the API. That is one. Two, we can use API testing tools like, that one is very common, Postman, which is an application for testing and using REST APIs. It contains everything required for constructing and sending REST API requests, including entering query parameters. Then we can use programming languages like Python. We can also use operating systems, netconfig, or REST config. Network operating systems are beginning to provide an alternative method for configuration, monitoring, and management. So this one, do not assist in network automation. So when we talk of network automation, we will talk of netconf and restconf. We also talk of programming via Python when we are configuring our networks to be automated. Right. Configuration management tools, traditional network configuration. Now putting everything into context. To discuss some data formats, if I discuss what automation is and the reasons why we need automation. Right? Then vatapina my data formats. Then what else? Lastly, we're discussing my APIs. Vatapina my APIs, RESTful APIs to be more specific. All those are going to be applied in networks. And to start and understand Quadruguva, we have the traditional network configuration where my devices, you get access to them via SSH. via console, make my configurations device one by one, which is a problem. I think we already discussed that. Very inefficient. In a large network, it's very time consuming, and that defines traditional network configurations. It's a problem, as we can see, an issue on large networks or with more complex configurations. We also have SNMP. I think with SNMP, we can push some configurations. We have quite a number of configurations that we can push via SNMP. We can also remotely monitor some devices. So that is an element, maybe not of automation, but of remotely managing some devices instead of being physically present, managing a device one by one. So SNMP allows us to remotely manage as well as remotely configure my devices. However, kana network yakura, it becomes very difficult. Security, yepa SNMP is also suspect. So it means SNMP for much larger networks with much important information being transmitted between devices is not an option. And that defines our traditional network configuration. With the use of my APIs and all the data formats that are running, we have what we call network automation, which is a solution to all the problems of our traditional methods of managing my networks. Network automation definition, we have already discussed that. The use of software, the use of technology to automate the configuration, not only configuration, but also management of network devices. Right? We are rapidly moving away from a world where administrators manages a few dozen network devices to one where they are deploying and managing a great number of complex network devices with the help of software, basically defining what we call network automation. And the couple number of protocols and technologies that we use. Duarapa, right here. So we have Puppet, tools, Ansible, Python, programming languages, Chef, tools, SwordStack, data formats, JSON or XML, JSON, RPC, OpenStack, NetConf, RESTconf, REST, with assistance of the cloud, obviously, and web applications. So these are some of the tools, the protocols, technologies that we will be using for network automation. Configuration management tools make use of RESTful API requests to automate tasks and can scale across thousands of devices. Like the example at when you are making a reservation online for a hotel or for a flight, instead of having access to one database, you can use an API which makes multiple API calls and requests information from multiple databases. So that same concept is used in network automation. We have multiple devices in a network. You use an API to get information or to forward information to multiple devices. And this helps in automating software and version control, protocol configurations, ACL configurations. I think some of the simple tasks, there is some VLANs, even with some IP addresses, assigning my IP addresses, that can be automated easily. Assigning my host names, automated easily. My ACLs, automated easily with the use of my APIs. And some of the tools available, we have Ansible, Chef, Puppet, SwordStack. I think At this level, knowledge yamunofana kuita is just knowing some of these tools, right? Ansible, Chef, Puppet, and SoftStack, and a comparison of those tools. And here we have a brief comparison of Ansible, Chef, Puppet, and SoftStack. Starting with the programming language, Ansible using Python, SoftStack as well using Python, Chef and Puppet using Ruby, right? Agent-based or agentless. Ansible is agentless, Puppet and SoftStack supporting both. When you talk of agent-based or agentless, what's that? Right, it's basically, when you talk of agent-based, it means devices have to be configured with the software so that your network automation tool is able to operate. And when you talk of an agentless tool, it means you don't need to install a software on it. It works, the device works without a software, basically. So I think the ones that are good to use are agentless. In this example, Ansible is agentless. It means no software is required to run. You don't need to install any software on the devices, especially on the device which is controlling or managing the central device, right? How are devices managed? Any device can be controller. In the other ones, we have a Chef Master, Puppet Master, Salt Master. What is created by the two? Playbook, cookbook, manifest, pillar. Matchmaking, Ansible, cookbook, Chef, Ansible playbook, Chef, cookbook, Puppet, manifest, SoftStack, pillar. I think these are typical questions as well. Knowledge of programming, not necessary, but just understanding the basics. For example, in our network automation tools, Ansible, what is created is a playbook, we have a cookbook, we have a manifest, and we have a pillar. So basic comparison, here are the tools that we have. There it is. Okay, lastly, we have intent-based networking. And to summarize what IBN is, this is the software-defined networking of Cisco. When we talk of automation, others, they call automated networks software-defined networks. Cisco calls them intent-based networks. That's the only difference. So IBN is a Cisco version of SDNs. I'll continue with the last session. I think last 15 minutes. My time is up for this one.